So we are continuing working on homework 4.1, 3, and 4. And we stopped at question number 10. So we pick question number 10, and let's continue all the way till question number 20. So find the area under the given curve over the indicated interval. It's given y is equal 3. Here we have y is equal 3. And we need to find the area under the graph y is equal 3. Well, since the graph is given, I could calculate easily this one. See, horizontally I have 4 the squares, vertically I have 3. 4 times 3 is 12. But I'm going to show you how to use integral to calculate the area. So first of all, what we have here and this is our let me see, this one. This is y is equal 3, and we need to find the shade. I'm shading here. Area under y is equal 3, and it's limited by, here it is, x is negative 2 and positive 2. Yes, here it is. X is between negative 2 and positive 2, since square bracket, negative 2 and positive 2 is included. Since the graph is pretty easy, so I could take and calculate. There's like I did already. There was how many? 3 of here, and it's supposed to be 1, 2, 3, 4 there. So I didn't keep proportion, but use your imagination. Proportion has to be kept, obviously. Now we have y is equal 3 on the interval between negative 2 and positive 2. Well, let's find the area, because remember at the very beginning I told you that via integral we can calculate perimeter, area, volume. So how we do that for area? It's asking area. I'm going to take integral 3 d. I'm going to take interval 3 dx, dy. Okay, because we have y. So this is going to be how much? 3y, correct? Okay, based on our formula for derivative and integral, it doesn't matter. So to remind you, I'm going to remind you formula for integral. Integral of constant dx is equal kx. Now we have, instead of dx, we have dy. I took dy because we have y here, and we get 3y, right? And next we need to find this 3y for function. Let me write down like that. 3y, it's for interval negative 2 to positive 2. Okay, so it's going to be, which means y I'm going to replace with 2. So I'm using from this limit on the graph till this limit, right? So 3 of 2 minus 3 of negative 2. And we are getting 6. It's going to be plus 6, and we get 12, right? We have negative, negative, so it's going to be plus 6. Positive 12. Let's plug the answer, and we check. Very good. Moving to question number 11. Let's see what we have here in this case. So now we have linear equation 2x, right? We have linear equation 2x, and we're gonna solve this one. So what do we have? I'm going to take integral of 2x and dx, and on interval 3 and 6. So if we check here, it's between 3 and 6 interval. Let me show you. So this is the graph, 2x, and when I say 3 and 6, that's what I mean, 3 and 6. Okay, and let me see. We need to find this area. So how are we gonna work it this out? We have y is equal 3x, right? Yes, y is equal 2x, okay, sorry. Y is equal, I didn't have written, y is equal 2x, question number 2, and it's on interval 3 and 6. Again, it's the square bracket, so which means 3 and 6 are included. So to find the interval, I'm taking, to find the area, I'm taking integral 2x dx, and remember, integral of x dx is going to be equal x to power n plus 1 divided by n plus 1, and plus constant. I forgot here to put constant. Now, why we didn't put with 12 constant? Because we have already the value. We don't get in the general form, algebraic form, let's say 3x plus 5. Okay? This is why in the case of area 12, we didn't put c. So here also we are not going to put plus constant because we have specific interval where to find. So this is going to be, 2 is going to get out, right? It's a constant, x and dx, which is going to be 2x squared over 2. This is gone, 2 and 2, and practically we have x squared on interval, lowest come here, highest come there. And we are plugging, instead of x, 6 squared and minus 3 squared, which is going to be 36 minus 9, it's going to be 27. Okay, let's plug the answer. Excellent. Moving to question number 12. Let's see what we have here. All right. So we're going to work with x cube, and this is shape of x cube. It should continue going down. It just have only first half, positive half. That's all right. So let's figure it out. Okay. So x cube on interval 0 and 2. Okay. Y is equal x cube on interval 0 and 2. So we get integral x cube dx, which is going to be equal x to power 4 over 4, right? And we are plugging here in interval 0 and 2. So first I'm going to plug x as a 2 to power 4 divided by 4, and then minus, well, 0. I don't need to plug anything. So 2 to power 4 is 16 divided by 4, and we are getting 4. Let's plug the answer. Good job. Moving to question number 13. All right. Now see, it doesn't give you any curve anymore. It just gives you the expression of a curve 9 over x. So it says find the area between the curve and x-axis over indicated interval. So 9 over x, and we get on interval 1 and 6. All right, let's start working. Over x, and this is, let me write down problem number 13, and it was on interval, one more double check, 1 and 6. Okay. So pretty straightforward. So 9 over x dx, it's going to be equal 9, I'm taking out, and we are getting 1 over x dx. That is going to be 9, and integral of 1 over x dx is natural log of x, right? Okay. So from here, I'm going to plug let me move this a little bit higher, and I am getting here, oops, I'm sorry, this is square bracket, parenthesis meaning it's not included, so it's going to be here 1, 2, 6. So evidently we need the calculator for natural log, right? So scientific, I'm looking, I have it. So it's going to be, it's in your phone, it's on desktop also calculator. So I will have 9 natural log of 6 and minus natural log of 1. So natural log of 6, I got 1.8, 1.8, okay. So it's going to be 9 times 1.8 and minus, how much it's gonna be? Natural log of 1, it's gonna be 0. Because why? You need to know any type of log, be it natural log, be it log by base 10, or be it any other log by base or any base, as long as it's 1, it's going to be equal 0. Let me remind you. So here, natural log meaning e, right? E to power 0. So any base here is 10. 10 to power 0. A to power 0. It's going to be always equal 1. Okay? All right. This is y. So, and we are getting 9 times 1.8. That's all we have left. And we are getting 16.2. Okay, let's check. 16.2, let's plug the answer. Type an exact answer. Well, how exact? It has to be, okay, well, we try to put in the form of logarithm then, which is gonna be 9 logarithm 6. That's what's gonna be exact. Otherwise, everything else is gonna be not exact. It's gonna be approximate. Since this is gonna be equal, oops, this is gonna be equal 0, right? So we get 9 times logarithm 6. So we plug in just like that. 9 times natural log 6. Fantastic work. Moving to question number 14. Evaluate. Okay, so we are going to take integral. So instead of giving telling us find the integral on interval 1, 4, it's just putting top and bottom. That means in between 1 and 4 integral. Let me see, 5x squared plus 3. 5x squared plus 3 dx. Instead of writing down between 1 and 6, right? It was 1 and 6. 1 and 4, okay. Instead of 1 and 4, we are writing right here. That's exactly same thing. So the same way, we are going to find 5x squared plus 3. 1 second, let me double check. Yeah, because I have a habit to make some silly mistake. Instead of 3, put 2. Not attentive. So this is going to be equal 1 and 4. This time I'm going to go step by step again. 5x squared dx, and then plus 1, 4, 3 dx. So, and we get 5x squared, it's going to be 5 x cubed over 3, right? Let me move this down. 5 over 3 x cubed. And then plus, what do we have? We have 3. That's going to be 3x, right? And all this I'm going to do for interval 1 and 4. So you can do separate. It still will be fine. Like, let's see, this way. 5 over 3 x cubed, 1 and 4, and then plus 3x, 1 and 4. It's absolutely no difference. I like to put this way all together. So I'm going to work with this way. You can work the way you like. It doesn't matter at all. Okay. And we are getting. So first I'm plugging the 4 in every x. So 5 over 3, 4 to power 3, right? And then plus 3 times 4. Now I'm going to do minus. Because I have minus, it's 1. So it's going to be, okay, let me put in parentheses since I'm doing this first time. 5 over 3, 1 to power 3, plus 3 times 1. Why did I put in parentheses? Because we have here subtraction and it's going to flip the sign, right? So let's work on it. 5 over 3, 4 to power 3, 4 times 4 is 16, 16 times 4 is 64. And then plus 12, minus, it's going to be 5 over 3, because 1 cubed is 1, doesn't do anything. And then minus 4, see that? Okay, because we have negative sign in front of parentheses. So what do we get? Practically 5 times 64, 5 times 4 is 20, 2 in mind, 5 times 6 is 30, and 32. 320 over 3. Now I want to combine these two together for now, because minus 5 over 3 and plus 8. Yes? Okay. And we are getting what? Let's figure it out. 20 over 3 minus 5 over 3. And I have here 8. I don't know if I should leave it 8 just like that or convert. Maybe let's do 3 also here, 3 here, 3 here, bring to common denominator. Okay, but very important notice here, since we don't have equation, we do not dare to drop denominator, okay? Because we don't have here equation, we don't have it equal to this. This is just a expression that we are simplifying. Therefore, we are going to keep that denominator free. You can drop denominator only and only if you have equation. So here we are going to get common free denominator. We keep it, obviously. 320 minus 5 and plus 24. Okay? So, and we are getting 315. 320 minus 5 is 315. And plus 24. And we are getting 339 over 3. I have good news for you. We can simplify, reduce by 3, because 339, how you can find out if you can divide or not? Well, first of all, here it's clearly we can see 339, but if we couldn't see, you just take and add numbers. Let's say 339. 3 plus 3 plus 9. 6 plus 9 is 15. 15 dividable by 3, that means the whole number is divisible by 3. Okay? If some of these digits you can divide by 3, that means this number is divisible by 3. But in this case, we don't even need to add, because 339 is clearly divisible by 3. And we are getting 113. So let's plug the answer and see what we get. Incorrect. Let's go back and check, see what we got. It must be some silly mistake. So first of all, 5x squared plus 3. 5x squared plus 3 and 1 and 4. Okay. Plus 3, 1 and 4. So I'm getting 5 over x squared. This one is gonna be x cubed over 3, and 5 also stays, right? 5 over 3 x cubed, and then 3 is gonna be 3x if you take out of integral, so 3x, and it's gonna be from 1 to 4. Okay, let's do it again. X cubed, we plug 4 cubed, okay, and then plus 3 times 4. 4 cubed is 64, 5 times 64. Let me punch on calculator, because last time I multiplied myself, just in case. 5 times 64, I'm getting 320, very good, divided by 3. Okay, and then plus this 3 times 4 is 12, here it is. And then we do, let me see, I'm going to take this one, minus 5 over 3, and then we get minus, here it is, silly mistake, see, minus 3. I'm pretty sure some of you saw that mistake a while ago and you were wondering what's happening. So 12 minus 3, let me take from here. It's going to be minus 5 over 3. Here we are going to clean. Instead of 8, we are going to get 9. So it's going to be, because 12 minus 3 is 9. 9 and 3 and 3, right? So this way 9 times 3, it's going to be, we are getting here 27. Okay, so I have to do, I added Okay, so 315 and plus 27, and I'm getting 342 over 3. Let's see if I can reduce 3 plus 4 plus 2. 3 plus 4 is 7. 7 plus 2 is 9, which means I can divide by 3. Is 1, 1, 4. Okay, let's go back to answer. Well done. Like I said, math and silly mistake always goes hand by hand. All right, what we are going to do here, we are going to deal with a square root. Okay, how are we gonna deal with a square root? So we get from 1 to 4 again, square root x minus 3. All right. Question number 15. Was it 15? Let me double check. Minus 3. Where from I got 15? Okay. My God. All right. So to solve this type of problem, we are going to represent the square root of x. Let me put different color so you would see. I'm drafting square root of x. I can represent as x to power 1 over 2, right? Because here is 1 degree, here meaning 2. So this 1 goes to numerator, 2 goes to denominator. So another one, if I have 3, here I have x to power 4. It's going to be x to power 4 over 3, okay? So back to our problem. This is going to be between 1 and 4. It's going to be x to power 1/2 minus 3 dx. So x to power 1/2 integral, it's going to be x to power 1/2 plus 1 over 1/2 plus 1. So 1 and 1/2, it's going to be 3 over 2, right? X and 3 over 2 divided by 3 over 2, which means if I divide flip, it's going to be 2 over 3, x to power 3 over 2. When we divide, we flip the fraction. Look, x to power 3 over 2 divided by 3 over 2. This is equal x to power 3 over 2. Since it's division, I flip it, multiply 2 over 3. And I'm getting 2/3 x to power 3 over 2. Okay? So I'm getting 2/3 x to power 3 over 2, and then minus 3, it's going to be minus 3x, right? Put in parentheses, and here I put negative 1, 1 and 4. Yes? Let's plug. First we're going to plug 4, and we are getting 2 over 3 x to 3 over 2 minus 3x 1 and 4. Let's get going. 2/3 4 to power 3 over 2 minus 3 times 4, and then minus, let me move this or I can clean it, we don't need this anymore. and we're gonna get minus in parentheses. Actually, yeah, minus 2 over 3, excuse me, 2 over 3, and we get now plugging 1 to power 3 over 2, and minus 3 times 1. All right, let's get going. 4 to power 3 over 2. If I rewrite back, see this number is coming here, and this one is coming here. So we are getting 4 to power 3, and here we have 2, or we don't put that 2, right? By default, we know if it's square root, that means 4 to power 3. Okay, let's see how much it's gonna be. 4 to power 3 is square root of 64, which is gonna be equal 8. Okay, so we are getting 2 over 3 times 8 minus 12, okay, minus, here this is going to be equal 1, because 1 to any power you raise, you still get 1. 2 over 3, and because we have negative sign in front, here we end up with plus 3. Okay, well, let's combine now, like terms, see what we're going to get. So 2 times 8, I'm getting 16 over 3 minus 12 minus 2 over 3 and plus 3. This is going to be equal. Look, 16 over 3 and minus 2 over 3. Since both of them have the same denominator, I can subtract 16 minus 2. It's going to be 14 over 3. And negative 12 and 3, it's going to be minus 9, right? The same way you could combine this way fractions first in the previous problem also. Let me see, where did we have it? Yeah, 320 minus these two. We could combine because both of them had 3 and put 315 over 3, right? But we did it anyway, sooner or later. Now I noticed sooner, so I'm putting sooner. 14 over 3 and then minus 9. All right, so since answer required in the format of fraction, be it proper fraction or improper fraction, so the easiest way to do is put here 3 and here 3. Bring to the common denominator, and result is going to be, here is 3, 14 minus 27, and we get negative 13 over 3, right? Let's put the answer. This is gonna be negative 13 over 3. Okay, nice work. Moving to question number 16. So we are going to solve a definite integral. By the way, the integrals that have the interval, which is in this case is negative 2 and 5, these integrals we call definite. And the ones that we solved before and they didn't have interval, we call indefinite integrals. Okay, so let's solve. Let me take a picture so I won't mess it up. Okay. We are solving question number 16, and we have integral from negative 2 to 5 and 4x squared minus 5x plus 5 and dx. Okay. We're already familiar with such cases and we can solve it. Let's see what we're gonna get here. So I'm not going to separate them anymore because you know that you can separate. All I'm going to do, just solve it. So 4x squared integral is gonna be 4x cubed over 3, right? N plus 1 over 3 over n plus 1 minus 5 times, it's going to be x squared over 2 because it's 1 plus 1 is 2, and plus in this case is going to be 5x, correct? So, and we put this on interval -2 and 5, and we can start figuring out. So first we put everywhere 5 and then minus everywhere we plug -2. Like I said, you can plug this interval separate also, it doesn't matter either way. I don't like to play piece by piece, so I'm just going to plug everything together. So first I'm plugging 5. 4 times 5 cubed over 3 minus 5 times 5 squared over 2 plus 5 times 5, okay, now minus, and I'm going to plug, actually I can take this parenthesis off, I don't need this parenthesis I will need here because I have negative, so 4 times -2 to power 3 over 3 minus 5 times -2 to power 2 over 2 and plus 5 times -2. All right, let's get going. So this is going to be 5 cubed is 125, and 125, okay, times 4, and I was thinking it's 600, so 500. 500 over 3 minus 5 squared is 25 times 5, 125 over 2 and plus 25. Next, minus, what do we have? -2 to power 3 is -8. So 4 times -8 because we are doing cube. So -2, -2, -2, it's going to give us -8 over 3. Here going to be 5 times -2 squared is going to be 4 over 2. And, oops, I'm sorry, we are opening parentheses, so it's going to be plus. And minus here, so hold on, we are going to get minus -10. Yes? Let me double check. 4 times -8 over 3 plus 5 times 4 over 2 and minus 5 times -10. Okay, now let's clear all this the signs. We are going to get 500 over 3 minus 125 over 2 plus 25. It's going to be here plus, because this -8 and this negative is going to be plus 32 over 3 plus 20 over 2 and plus 10. So let's combine like terms. I'm going to combine this the denominator 3 with this denominator 3, this denominator 2 with this denominator 2, and this available term, I mean the whole number 25 and 10. Well, let's do it. So let's first one, 500 over 3 and 32 over 3. We are getting, since it's addition everywhere, 532 over 3. Next, with denominator 2, negative, we have negative 125 and plus 20. So we need to subtract, and it's going to be negative. So 5, 2 minus 2 is 0, and 105 over 2. And 25 plus 10 is 35. Okay, so from here, what we can do? We need to combine denominator 3 and 2. So let me see. I'm doing some math. 1 second. Yeah. So I'm going to bring two common denominator. So 3 and 2, denominator is going to be 6, right? Which means here I'm multiplying by 2, accordingly here to get 6. I have here 2 to get 6, I'm multiplying by 3, multiplying by 3. Here I have 1, so I have to divide by 6 and multiply by 6. Why 6, guys? Because we have 3 and 2, and common is going to be 6, right? Because only 6 is divisible by 3 and 6 divisible by 2. Correct? So let's see what we're going to do from here. It is going to be 532 times 2. 2 times 2 is 4, 6, and 10. Okay, minus 315 and plus 6 times 5 is 30, 3 in mind, 6 times 3 is 18, and 3, 21. Okay, so, well, I'm going to punch on calculator real fast. I don't want to do by hand. So 1064 minus 315 and plus 210. I'm getting 959 over 6. Since my 6 is divisible by 3, let me see if 959 also divisible by 3. 9 plus 5 plus 9. 9 plus 5 is 14. 14 plus 9 is 23. Nope, we can't reduce, so we get stuck. This is going to be our answer, 959 over 6. Let's go ahead. (959) over 6. We are getting fantastic work done. Number 17. This is going to be interesting. So, what do we have? E to power t dt. E to power t dt. So, how are we gonna solve? This is number 17. And we are getting from -1 to 3 e to power t dt. All right. So integral e to power t dt is equal e to power t. Just like e to power x prime is equal e to power x. Okay? Therefore, integral also going to be different. Well, I can put here t, doesn't matter. That will help you. Okay? So let's work. It's going to be here from, was it -1? Let me double check. Yes, -1. And practically we are getting e to power t from -1 to 3. So what we're gonna do, we're gonna do e to power 3 minus e to power -1. Okay? So let me see if they want to plug. No, we are going to plug the way it is. E to power 3 minus e to power -1. Where is my e? Okay, I didn't want more. Hold on. E to power 3 minus, where was my e? I had it and I lost it. Where is my e? 1 second, I'll find it. Ah, here it is. The e to power -1. There we go. Did I put negative? No. -1. Good job. So moving to question number, which one was that? Question number 18. All right, we are moving question number 18. We are close to finishing. So how are we gonna solve this problem? This is gonna be, let me take a picture of it. Otherwise I won't be able to write down. I know myself, I'll make mistake. Typo rather saying, not mistake. Okay. Number 18. It's going to be integral from 1 to e to power 2. And I get 2x. Let me see. And I get 2x plus 4 over x and dx. All right? So let's start working. First of all, we're going to take integral of 2x. It's going to be 2x squared over 2, right? This is gone. Put here parentheses. Plus, this is going to be 4 times 1 over x, right? We are going to get logarithm. 4 logarithm x. Remember, derivative 1 over x, derivative of natural logarithm x is equal 1 over x, and accordingly 1 over x dx is equal natural log x. Remember that? Okay, so natural log x, and we are going to do it on interval e and 1 and e squared. Okay, so let's start working. So we get e squared to power 2, right? and then plus 4 times natural log e squared, and then minus everything plugging with 1, it's going to be 1 squared. I don't know why I keep putting up, it seems to me there is fraction, and then plus 4 times natural log 1. Okay, and we are getting e to power 4 plus 4 times, how much will be natural log e squared? When we have natural log e, that is equal 1, right? Because base is e. So a to power 1, we get e. Now what if we have e squared? Just like our case. Logarithm e squared. And so for natural logarithm, base is e, right? That means we need to raise to power 2, right? To get e to power 2. Which means we are going to get 4 times 2. Minus 1 squared is 1, and then minus 4 times logarithm 1. Logarithm 1 is 0, right? Let me go over. Here is e. I have to raise to power 0 to get 1. Right? Okay. 0. 4 times 0 is 0. And the result is e to power 4 plus 8 minus 1 is plus 7. E to power 4 plus 7. Okay? Well, let me plug the answer. Nice work. Now, since I have here the whole numbers, it doesn't mean necessarily you will have whole number as an answer. You very likely also can have fractions, so don't be scared. Whatever answer comes out, that's good enough. Okay? So, next, what we are going to do in this case? We are given area that is bounded with 2 graphs. One is linear, one is parabola. And we have x to power 5 and we have 16x. So in the interval is going to be between 0 and 2. Since we have here 0 and 2, here is C has beginning of interval 0, and then A have beginning interval of 0. The B has ending boundary as a 3, and we don't have it. It's 0 and 2. That means it's going to be either A or C. Next, we have 2 graphs, right? 16x and x to 5. The top boundary is going to be our linear equation, 16x. Bottom boundary, okay, let me draw this so we can understand. One comes this way, another one comes this way. So this is the shaded area. So this one is, how much was that? Linear equation, doesn't matter at this point, 16x and x to 5, okay. This one is 16x, this one is x to 5. So we need to take top boundary, 16x, and minus bottom boundary, x to 5. And because we need to find the area, and this is not a rectangle, triangle, or any right shape, so we need to take integral. Okay? And dx, and limit was from 0 to 2. Obviously this is 0, and 2 is going to be somewhere here. And that's all. So let's plug. Which one it's gonna be? I'm going to plug this one, 0 and 2. Here I don't put here because it's plus, I need minus, right? 0, this is gonna be 2, right? And here I'm going to put 16x, top boundary, minus x to 5, to power 5. I am, where is my parentheses? Here it is. This is, I'm closing. Oh no, this is curly braces. Oh, here it is. And this is opening. I don't know, do they have it here? Let me see. Oh, fantastic. I was going to check if they already have parentheses there, and it didn't even show, and just got it, so we got it right. Parentheses were missing. Ah, 2 parentheses, that's okay. So you don't have to put parentheses because they had it. I didn't know. I put and I wanted to check, and it just took me to right for checkup. So now we need to find the area, which means what do we have to do? We need to solve it. Let's solve this one. So from 0 to 2, 16x minus x to 5 dx. This is going to be 16x squared over 2 okay, and then minus, we are going to get x to 6 over 6, and all this, it's gonna be all this is gonna be this 0. Let me put 0 here. Okay, all this is gonna be on interval 0 and 2. So we get 16 and 2, 1 and 8, right? So we are getting 8 times 2 squared. I'm plugging 2 everywhere right now, minus 2 to power 6 over 6, and then minus now I'm going to plug 0. Okay, so this is gonna be 0 and 0, so okay, we are done. There is nothing in there. So this is gonna be it, and the result is 2 to power 2 is 4. 4 times 8, 32, minus 2 to power 6. 2 to power 3 is 8. 60, it should be 64. 2 to power 3, and I'm breaking down like this: 2 to power 6. 2 to power 3 times 2 to power 3 will be 2 to power 6, right? 2 to power 3 is 8. So 8 times 8, gonna be 64. That's how I did. 64 over 6. I can't divide, but at least I can reduce. By 2, it's gonna be 3. By 2, it's gonna be 32. So we are getting 32 minus 32 over 3. Let me bring to common denominator 3 here, and we are getting how much? And we are getting 3 times 2 is 6, here is 9 over 3, and minus 32, and we get 64. 64 over 3. Let's plug in and see what's happening. The area is 64 over 3. Well done. So when you have, let's say, some figure given here, you need to find the area. So you find what is on the, what border is on the top, how it's expressed mathematically, and what is at the bottom. Now this time, this curve is on the top, upper boundary, and the expression, linear graph is at the bottom. So this time we are going to do curve minus linear expression. Yes? And that is going to be, what do we have? So since the boundary is not given, but what does it say? Find the area of region bounded by graphs of the given equation. Okay, by graphs. All right, let's see. This is, how much is this? 1. This is 1, x is 1, and then 1, 2, 3, 4, 5. Okay, let me draw here so you will see. This is number 19. This is how we have this graph. So this is, if you look, it's 1, and this is coming 5. Let me double check. Yeah, on the top, oh, I see x is 0, I'm sorry. This is our y. Okay, it's going, x is 0, y is 1, this point. So it's going to be from 0, 1, 2, 3, 4. Okay, let me show you how it goes. So this is how it goes, like this. So this is x is 0 here, right? Y is 1, but we need to, interval we find by x, and accordingly this is going to be 4, not 5. All right, so let's write down. Since we have the 0 and 4, okay, so here we are going to have, what is the curve of, for the expression of curve? Square root, radical degree 6 over x. Let me see, here it is. This is going to be 6, no, this one. How can I get, this is going to be x, and this is, how to get to, 6. Hallelujah. I got it. And minus x. Make sure your minus won't get under radical, otherwise you will get wrong answer. Huh. Let's see. I'm sorry. What is this? Is it possible? I want to see the parentheses. Did I put? Maybe we have to put parentheses in there. I don't know, because we have correct. And we have their square bracket, but I don't know. Let's check it. I'm going to put parentheses. It's a software, one never know. Okay. All right, I'm opening. We have 1, 2, 3, 4, from 0 to 4. I don't see any wrong doings. Let's say what is wrong doing. What is 1? One and 4. And why we don't put parentheses? Oh, they don't want to put parentheses. Okay, so we were right first time. we don't need to put, but why is it 1? Let me read the problem again. Oh, 0 and 1. How is it going to... Okay, this is 0.25 is given, so 1, 2, 3, 4, 4 times. That's crazy. Oh, on y, see where is 1? 1, 2, 3, 4, 1, 2, 3, 4. 4 squares, it make 1. So we have here, instead of 4 squares, it makes 1. Okay, we should put 1. But parentheses is not you don't have to put parentheses. I thought software demanding because it doesn't have to be. First time I didn't put it. Okay, well, just measurement, they put it the way that on y on the top, see here 1, so that measures 1, 2, 3, 4 cells is 1, which means this 4 I counted horizontally 4 cells, that the realistically supposed to be 1. All right. Oh, this is question number 20. We solved. Did we solve number 19? Yeah, we did. And this is like that. Now we need to solve also the area, find the area, and we are done. So 0, 1, let me write down. Come on. Where is it? So it's going to be 0. Instead of 4, we are going to have 1. Because this, we had here 1, 2, 3, 4, and there was 1 here. Therefore, 1, 2, 3, and 4. This was 1 here. So we have from 0 to 1, radical square at the radical degree 6 of x, and it was minus x. Yes. Radical degree 6x minus x, correct. 0, 1. Okay. Well, let's solve it. So dx. Here, why I put the parentheses? Because I didn't put square brackets. In the answer, it has already square bracket. That's good enough. No clue why they put square bracket instead of parentheses, but it is what it is. Because square bracket, parentheses will be good enough. No need to use square brackets. Anyway, we are getting from here, it's going to be from 0 to 1, x to power 1 over 6, right? Rational exponent, minus x dx. And what do we get? X to power 1, 6 plus 1. 1, 6 plus 1. I'm getting 1 and 1, 6, which will be 6 and 1, 7 over 6. I'm multiplying. 1 times 6 is 6, and plus 1 is 7 over 6. So I'm getting x 7 over 6 divided by 7 over 6. And minus, this is going to be x squared over 2. And all this going to be between, on interval 0 and 1. Okay? So, we are getting, since we are dividing, this bottom fraction is going to flip. We are getting 6 over 7, x to power 7 over 6, minus x squared over 2, and 0 and 1. Evidently 0 we're going to throw out a window because it's going to be all 0. We're going to plug 1. And we are getting 6 over 7, 1 to power 7 over 6, and minus 1 squared over 2. And answer is, this is going to be 1. 1 to any power is 1. So we get 6 over 7, and we get minus 1 over 2. We get 5 over 2. Right? Okay. Or 3 minus 1 half, 2 and half. 5 over 2 is 2 and half. Well, let's put the answer. Again. wondering in what format it wants. So let me do it again. Let's solve it again, okay? I'm not going to check, I'm just going to solve it again. So integral 0 and 1, x to power 1 over 6, because radical 6, okay, minus x and dx. So we are getting x to power 1 over 6 plus 1 over 1 over 6 plus 1. I'm going slow, not to have any silly mistake. Square. Okay, and here we are getting 0 and 1. So 1 plus 1 over 6, it's going to be 7 over 6. So x to power 7 over 6 divided by 7 over 6, we are getting times 6 over 7 and minus x squared over 2. So all this, it's going to be on interval 0 and 1. So 6 over 7 and 1 to any degree, it's going to be 1. So 6 over 7. Gee, here supposed to be 6 over 7. I'm pretty sure many of you noticed. Okay, 6 over 7 minus 1 half. Then just maybe might as well, let's finish this one, huh? 6 over 7 minus 1 half. What we gonna do? Common denominator is gonna be what? 7 is a prime number. Real quick, prime number is a number that is divisible by 1 and by itself. So when you have prime number, then you have to multiply by each other for a denominator, meaning 7 times 2, 14. That's mean here I multiply by 2 to get 14. Here multiply by 7. And my answer is going to be, both of them are 14. Now I can 6 times 2 minus 1 times 7. And we are getting, this is 14. 6 times 2 is 12 minus 7. And I am getting 5 over 14. We need to fix this 14. Okay, we got it. So, if you have any questions, guys, if you need any help, contact me right away, okay? I will be more than happy to help you out. Okie dokie.